Okay, here's a big question for you. How long until artificial intelligence could automate all human thinking work? Not just some tasks, but everything cognitive.
It sounds like pure sci-fi, doesn't it? But what's fascinating is that serious researchers are actually trying to forecast this now using models.
Yeah, and getting some, frankly, eye-opening answers. We're not just guessing anymore.
Exactly. We're moving into the realm of, well, sophisticated modeling, trying to put some timelines on it, a more data-driven peek into what might be coming.
And today, that's what we're digging into. We're looking at research from Tom Davidson, an AI impact expert. He's using economic modeling, which is interesting in itself, to forecast when we might hit 100% AI automation.
Right. So our goal here is really to unpack how he does it, what his models are actually predicting, and, what that could mean. Help you get a handle on the factors involved.
Because it's complex stuff. He even compares it to things like the Industrial Revolution.
Yeah, that's a key analogy for him. Back then, machines automated physical work. Now he's suggesting AI could do the same for, well, cognitive labor, thinking,
Yeah.
and maybe on a similar or possibly much faster track.
Okay, let's get into the model itself. Davidson's framework seems to have two core ideas, right?
That's right. First, there are AI timelines, basically trying to figure out when AI might hit certain key capability milestones.
The when and the second part.
And then AI takeoff speed. This is crucial. It's about how fast AI could potentially jump from being, say, roughly human level to way, way beyond human capabilities.
Okay, so when and how fast? And he defines these levels, like 20% AI.
Yeah, he uses markers. So 20% AI would mean AI capable of automating about 1/5 of the cognitive tasks humans currently do.
And 100% AI is everything, the whole cognitive shebang.
Pretty much, automating all of it. It gives us a scale to think about this progression.
Now, the jump from 20% to 100%, Davidson estimates that needs something like a 10,000 times increase in compute power or algorithmic efficiency.
1,000 times, yeah.
That number just sounds huge, almost impossible. How does the model suggest we could possibly bridge that kind of gap?
Well, it's definitely a massive leap, but the idea isn't that it comes from one single breakthrough. It's likely a combination.
Like what?
You could get there with much more powerful chips, better hardware, or simply by using vastly more chips than we do now, sheer scale.
Okay.
Or, and this is really important through much, much smarter algorithms, software innovations that let us do exponentially more with the hardware we already have. It's like getting way more miles per gallon.
So it's a mix and match of hardware and software improvements.
Yeah.
But the scale needed is still kind of mind-boggling.
Oh, absolutely. Even his lower estimates point to compute demands that are enormous. Think running today's biggest supercomputers flat out for years, maybe even longer. It's a serious resource question.
So what drives this kind of growth?
Wow.
How could we possibly get that 10,000x improvement? Davidson points to a few accelerators, right?
Yeah, several key things. First, just ongoing hardware improvements. Moore's law isn't dead, maybe it's slowed, but chips keep getting better or cheaper, or both.
Standard tech progress, okay.
Then you've got software breakthroughs. These are the algorithmic innovations, finding cleverer ways to make the AI learn or perform tasks using less compute. This can be just as powerful, if not more so, than better hardware sometimes.
Right, making the existing engines run way more efficiently.
Exactly. And then there are the feedback loops. This is where it gets really interesting, potentially explosive.
Explain that. What kind of feedback loops?
Well, the big one is AI helping to design better AI. If AI tools can accelerate research and development in AI itself, you get this self-reinforcing cycle. Better AI leads to faster progress on the next generation of AI.
Ah, okay. AI pulling itself up by its bootstraps, basically.
Sort of, yeah. And of course, as AI gets more capable and shows real economic value, what happens?
More money flows in. Investment.
Precisely. Increased investment fuels more research, attracts more talent, buys more compute, which speeds everything up again. Another reinforcing loop.
Which leads us neatly into his economic modeling work. He uses a specific tool, right? Something called a CES production function.
Yeah, the CES production function.
Mm.
Without getting too technical, think of it as an economic formula that models how different inputs like human workers and, say, automated systems combine to produce economic output.
So it helps model how automation substitutes for, or maybe works alongside, human labor.
Exactly. Davidson adapts it to look specifically at AI automation. How efficiently can AI step in for human cognitive tasks? How does that impact overall productivity and growth?
And does this model capture those feedback loops we just talked about?
Yes, that's a key part. It explicitly models how AI-driven R&D improvements in AI itself can dramatically speed things up. It's not just external factors. The AI's own progress becomes an internal engine for faster growth.
And the investment surge.
That's in there too. The model shows that once AI hits certain capability thresholds, making its value undeniable, investment is predicted to surge significantly, pouring fuel on the fire.
So it's not just a steady linear path. The model expects these bursts of acceleration as AI proves itself and starts improving itself.
That's the core idea, yes. It suggests periods of potentially very rapid change.
Okay, but forecasting the future, especially with something as unpredictable as AI, is risky. How does Davidson handle all the uncertainty? You mentioned simulations.
Right, he uses Monte Carlo simulations. It's a common technique when dealing with lots of unknowns.
How does it work, roughly?
Basically, instead of plugging in just one single guess for each variable, like the rate of hardware progress or the chance of an algorithmic breakthrough, you give the model a whole range of plausible values for each input.
Okay.
Then you run the simulation thousands, maybe millions of times, each time picking random values from within those plausible ranges.
So you're not getting just one answer, but a whole distribution of possible futures.
Exactly. It shows you not just the most likely outcome, but also the range of possibilities, how sensitive the results are to different assumptions. It gives you a feel for the uncertainty.
Smart. So what do these thousands of simulated futures point towards? What's the headline result?
Well, the median result, the one right in the middle of all the simulated outcomes, points towards hitting 100% AI automation around 2043.
2043. Okay, that's sooner than many might think, but still a couple of decades out.
True. But maybe the more startling number is the takeoff duration, the time it takes to go from that 20% automation level to the full 100%.
And that is,
The median estimate for that takeoff is only about 3 years.
wow. Okay, wait. So the model suggests we could go from AI doing a fifth of cognitive work to AI doing all of it in just 3 years, like 2040 to 2043, for example.
That's the median prediction, yes. Incredibly rapid acceleration once it gets
Fast, really fast.
Mhm.
But simulations give ranges, right? What are the extremes? Could it be much sooner or much later?
Absolutely. The simulations show a wide range. There's roughly a 10% chance, according to the model, that 100% AI arrives before 2030.
Before 2030, that's next decade, practically knocking on the door.
It's a possibility within the model's parameters. On the other end, there's also about a 10% chance it doesn't happen until after 2100.
Okay, so a huge spread. What pushes it way out like that?
Things like much slower progress in algorithms than expected. Maybe we hit fundamental roadblocks with current AI approaches, serious data limitations, or major bottlenecks in building the needed infrastructure like energy or chips.
And what about the takeoff speed? Could that 3-year window vary wildly too?
Oh, yes. In some outlier scenarios, the takeoff could be incredibly fast under 10 months, like a cliff edge.
Under a year.
Yeah. Or it could be much slower, dragging out for over 12 years in other scenarios if progress faces unexpected friction.
So the core takeaway here seems to be, forget slow and steady.
Pretty much.
Yeah.
The big message from Davidson's work is that this idea many people have that AI will just gradually, gently integrate over many decades might be wrong.
Even without some totally out-of-the-blue sci-fi breakthrough.
Exactly. Even based on extrapolating current trends and known mechanisms, the model suggests that once AI gets close to human level across a broad range of tasks, the final push to superhuman and full automation could be surprisingly quick, just a few years.
Because of those reinforcing factors. The feedback loops, the investment surges, AI helping itself.
Right. All these things create positive feedback that significantly shortens the timelines in the models. It seems quite hard, actually, within the model's logic, to push 100% AI much beyond, say, 2060, unless you assume the current entire AI paradigm just fundamentally hits a wall.
But what about external shocks? Like, say, a massive global recession hitting investment hard. Could that derail the fast timelines?
That's a really important point. And yes, a severe prolonged downturn could definitely slow things down by hitting investment, which is a key accelerator in the model. The model does account for some variability, but a major shock wasn't explicitly modeled as a primary scenario, I believe. However, the fact that it's still difficult in the model to push things past 2060 suggests the underlying drivers are quite strong. External factors might change the exact year or the precise speed, but the potential for rapid acceleration seems pretty baked into the dynamics, assuming the core technological path continues.
Now, we have to be realistic. This is a model. All models have assumptions, limitations.
Absolutely crucial to remember. Any forecast like this is only as good as the assumptions it's built on, and there are definitely potential blind spots.
Like what? What are the big what-ifs that could throw a wrench in the works?
Well, data could become a bottleneck. These models need vast amounts of data. What if we start running out or access becomes restricted?
Okay, data scarcity.
Or maybe the current way we build AI, deep learning and transformers and so on, hits fundamental limits we haven't foreseen yet. Maybe a whole new paradigm is needed, and we don't know how long that would take to discover or develop.
Paradigm shift, yeah.
Resource constraints are another big one. Can we actually build and power all the computing infrastructure needed? Energy demands, chip manufacturing capacity, these could become serious hurdles. Unknown unknowns are always the biggest risk in forecasting.
So it's not a crystal ball.
Definitely not. Like any good economic model, the real value here is less about guaranteeing the exact date 2043 or whatever, and more about framing our thinking.
Right. It helps us understand the dynamics, the potential speeds, the key factors to watch. It prompts discussion.
Exactly. It gives you a structured way to think about the possibilities rather than just throwing your hands up.
So bringing it back to you, the listener, what's the main thing to take away from Davidson's framework?
I think the bottom line is this. That common picture of AI slowly creeping into society might underestimate the potential speed. Even if you take the more conservative parts of these estimates, truly transformative AI seems plausible within a few decades.
And not just plausible, but with a real chance of arriving much sooner.
Yes. And critically, the transition itself, that period when AI goes from doing some things to doing basically all cognitive things, could be incredibly fast. Maybe just a handful of years.
Which is kind of staggering when you think about it. The Industrial Revolution reshaped the world over decades, generations even. This suggests a transformation potentially compressed into a much, much shorter time frame.
It really does shift your perspective. It forces you to consider that these aren't necessarily far future abstract possibilities. They could be relevant within your planning horizon, affecting careers, society, economics.
So the real insight isn't just the when, but the potential velocity of the change once it gets going.
That's the core, yeah. The speed at which AI might fully automate cognitive labor once it crosses certain thresholds is remarkable in these models, surprisingly fast.
Which leaves us with a pretty profound thought to chew on. If these forecasts are even remotely in the right ballpark, if this kind of rapid total automation of cognitive work is possible within your lifetime, what does that actually mean?
Right. How do you prepare? What does society look like? What skills matter? What new challenges and opportunities arise?
It's a huge question.
Yeah.
Definitely encourages you to keep digging into these topics, stay informed, and think critically about what such a rapid shift might entail.
Absolutely. It's less about having the definitive answer now and more about engaging with the possibilities and implications proactively. A lot to think about.